Hello, welcome to a new unit on complex numbers. In this unit, we are going to learn the different ways to express a complex number. The requirements are very basic. It is simply to know how to operate with complex numbers and to know the modulus and argument of a complex number. Well, we remember that a complex number in binomial form is written in the form a plus b I, where a is the real part and b is the imaginary part. I would be the imaginary number root of -1, or what is the same I squared is equal to -1. Well, we say that a complex number is written in the Cartesian form if we write it in the form of a vector in the complex plane. That is, we simply write a vector that has imaginary part a, comma, imaginary part b. We are going to express complex numbers in other ways. But to do so, we need to first review what was the modulus and the argument of a complex number. We recall that if we have a number a plus bi, its modulus is simply the square root of the real part squared plus the imaginary part squared. We also remember that the argument of a complex number was the angle it formed with respect to the real axis, and was calculated using the formula arctangent of the imaginary part divided by the real part, always taking into account the quadrant in which the z affix is located. Very well, let us remember a little how the graphical representation of the complex numbers in the complex plane was. Notice that on the real axis we represent the real part of the complex number a and the imaginary part on the imaginary axis. Well, as you can see, that would be the complex number a plus b times I. Alpha would be the argument and the modulus of z. As indicated, the modulus is the distance from 0 to the complex number a plus bi. If we remember what is the definition of the sine of alpha, this was the opposite leg split by the hypotenuse. In this case, if we mark the two values, we have that the opposite leg would be b, and the hypotenuse would be the modulus of z. Well, if in this expression we want to clear b, what we would do would be to pass the modulus of z multiplying to the other term. That is, we get that b is equal to the modulus of z times the sine of alpha. If we do the same with the cosine, we have that the cosine is contiguous cathetus divided by hypotenuse. In this case, it would be a divided by the modulus of zeta. If we want to clear a from this equation, what we have to do is pass the modulus of z to the other part by multiplying. Therefore, we would be left that a is equal to the modulus of z times the cosine of alpha. Look at these two expressions. b is equal to the modulus of z times the sine of alpha, and a is equal to the modulus of z times the cosine of alpha. Let's substitute a and b in the complex number in binomial form. That is, we would conclude that z is equal to the modulus of z times the cosine of alpha plus I times the modulus of z times the sine of alpha. Well, if you look at this term, we have that the modulus of z is multiplying both terms of the addition. We can take out the common factor and we would arrive at that expression, that z is equal to the modulus of z times, parentheses, the cosine of alpha plus I times the sine of alpha. This way of expressing a complex number is called trigonometric form. In general, if r is the modulus of the complex number z and alpha is its argument, the trigonometric form of z would be r times the cosine of alpha plus I times the sine of alpha. A more abbreviated way of expressing a complex number is the polar form. It is simply a matter of taking the modulus of the complex z, which is r, and putting the argument as the subscript. It is a much shorter and much simpler way to work with complex numbers. Well, let's look at an example and write it in all the ways of expressing a complex number. If we have the complex 1 plus I, we know that the modulus of z, which we're going to call r, would be the square root of the real part plus the imaginary part, both squared. If we calculate, it would simply be the root of 2, as you can see on the transparency. The argument? We apply the definition that we have seen previously, and it is the arctangent of the imaginary part divided by the real part. In this case, it is simply the arctangent of 1, which is p quarters. So, the binomial form, exactly what we had, 1 plus I, the Cartesian form, is to write that complex number as a vector, real part, comma, imaginary part, 1 to 1. The trigonometric form is very simple. If we know that the modulus is the root of 2, then we put the root of 2 by the cosine of the argument, which is pi quarters, plus I by the sine of the argument, which is pi quarters. Finally, the polar form would simply be to write the modulus and as a subscript the argument, which is p quarts. Well, so much for today's unit. Hopefully you understood how a complex number can be expressed in binomial, Cartesian, trigonometric, and polar form. Thank you very much.